Okay, hello. Not the talk that was originally planned here, but there was someone who could not come, and I took their place in the last moment. My topic here is about Rust on my bike. But before I begin, I can see that there are more people coming in. But a bit about myself. So, what can I say? I use spaces in my code, but I think tabs are better. I also never took the time to learn either Vim or Emacs. So now that I made sure that everyone hates me, I can begin the presentation. I also like bicycles, and I sometimes do crazy things like put Rust on my bicycle. I'm going to show you my bicycle. This is my bicycle. It's old, it's made of steel, and that's why it has Rust in some places. This is the actual picture that I took this morning. But I also put other kinds of Rust, which I don't know why it looks like this, but this is the Rust programming language logo. And this is the other kind of Rust that I feel is more welcome on my bike. So, who here knows what a bicycle computer is? There's a couple people. Okay. So my first bicycle computer looked kind of like that. I bought it about 20 years ago before I even knew how to program. It is a very simple mechanical device that you put next to your wheel, and it counts the rotations. And as a result, you see there is a little bit number 3 over there that shows presumably kilometers that you rode. It's a mechanical computer. After a couple years, actually not maybe even a year, I upgraded to an electronic one. This one is a bit more something that we might find on a bicycle today. It shows speed, it shows the distance traveled, it also shows the time that you cycled for now. But about the same time, 2 things happened. Well, after 10 years of cycling with this bicycle computer, I decided that this is like a really awesome thing. This was like the best investment of 20 euro in my life, judging by the amount of fun that I got out of it. But later I realized, or like I learned coding, and also another thing happened. The battery ran out. So after I learned coding, this was an obvious thing. I could do it better. So I decided to build my own. It turns out that after those so many years, the situation in the computing market changed between now and then. And I've been trying to go at this project for pretty much 10 years, and I was trying to build the next revision of the first and the next revision of my own hardware to base my bicycle computer off. But it was not really quite working. It was obvious that I'm much better at programming than electronics. And I saw that the market has really changed. There was a lot more smartphones. There is the Internet of Things. There's a lot of small devices that do their own little thing. And I have seen that there's also the kind of technology progress is making this into bicycle computers made by other people. So, for example, those are 2 Garmin devices. One is more in the direction of numbers, and the other one has maps. And I thought maybe this is something that I could just use. Maybe even I have seen people that are cycling with their phones on the handlebars. Perhaps I don't even really need to build a hardware device. Maybe I can just put my smartphone on the handlebars and call it a day. But there are two kinds of. Maybe there's many kinds of cyclists. Some cyclists cycle home and between home and work every day. Some cyclists go with their family. Some cyclists just go to see something interesting in the area. Some people try to do some training. But what kind of a cyclist am I? I decided that these two devices in particular, those show very different approaches. One gives you something like a map, and the other one gives you statistics. Which one do you think would be better for someone who is doing training, and which one would be better for someone who is going on a trip to the castle? So which one would be the better for the trip to the castle? On the left side or on the right side? Yeah, right side. So if you want to do training, which one would that be? It would be on the left side. And I know that I'm more of a cyclist that does the training kind of stuff. I usually cycle around my hometown, and I typically don't go so far that I actually don't know where I am. So I would probably not need any navigation capabilities. Do I really need a smartphone for that? Or would it be enough to have like a smaller device or simpler device? If I want to build my bicycle computer, then it should fit me, and it should not be too difficult. I am not a company which has millions of dollars to spend on development. So there was this consideration. But maybe I can just forget about it and put the smartphone anyway. Because smartphone has power. It has the batteries, and it has the communication and sensors. So I could theoretically do anything I wanted. Or could I not? But there are advantages to having a small device. A small device is like more aerodynamic. If I'm like pushing it really, then I don't want a big thing in front of my face that will just like cause turbulence or maybe shake away and fall out, just crash, and I lose what smartphones cost a lot of money those days. I don't really want to risk it. I don't want to risk that the rain catches me and my smartphone will get all wet. Maybe it's too much trouble. And if I want to hack on it, a smartphone typically can do like cycling assistance, can give me statistics. There's like apps like Strava or whatever, but they are not really very private. And I'm a person who like really does not like the surveillance capitalism that we have those days. So maybe I want to actually build some software myself from the ground up without all the downsides. And also maybe I want the hardware that actually really fits the use case that I want. So I decided, no, I don't want a smartwatch, so I'm going to look at the kind of smaller devices because, well, bike manufacturers already have those, and there are also smartwatches. There are fitness trackers, so I should be able to find something. But there are some problems. Most of the devices are not that focused on battery life, and battery life is very important if I want to ride every day. There's also another thing where a lot of the devices are focusing on, like, especially smartwatches, on being used indoors. They have screens that have backlights. They cannot always be read in strong sunlight. And this would be really required for a bike computer, that you can read it outside when the sun is shining and when you cannot really see because it's far away, so you have to have like good readability. You also want some buttons. Smartwatches don't always have many buttons or something. It was difficult, but I managed to find something. Actually, it wasn't me. It was a guy from Esperino, Gordon Williams. He found a smartwatch that he managed to reverse engineer. So it is quite well documented. There are no schematics, but the device is so simple that you don't really need schematics. This is in opposition to some of the devices that I found elsewhere, like those Garmin's. There is no documentation. How would I even flash it? I even encountered one device that was running a proper Linux system. And the problem with a Linux system is it's probably complicated. It probably needs a lot of resources. It probably takes a lot of battery. I was not sure if this was actually a good fit for me, because as I said, I want to hack on it and I want to have it simple. And I don't think anyone would like really put Linux on a simple device. So I just rejected that. Once I saw this one, I decided, yeah, this is my thing. It was not perfect. Like, it does not have a sound generator, for example, and it only has one button. But for the start, if I didn't take this one, I would probably never finish my project or never properly begin it. But now I had hardware, and there's the other big question. which operating system do I use? Or do I use any operating system at all? Maybe I can just write it on bare metal. There are so many choices. There is NATX, there's Mbed OS, there's FrOSCon, which is from the guy who discovered this hardware. There's Riot, there's Zephyr project. They all have their own strong sides, and they have all their weak sides. And yeah, I mentioned Rust in the beginning. I wanted to do Rust. If it's my hobby project, I want to enjoy it. I wrote enough C code that I don't really want to do it anymore. Of course, you can pay me, and I will gladly do it. I am also doing consulting, so keep that in mind. Coming back to Rust, there are two main paths. I noticed that someone wrote a tutorial for Riot where you can compile a Rust application, and it works, which is amazing. I was almost ready to go with it. I was also considering like the Rust embedded ecosystem, which is currently better suited for bare metal. But in the last moment, just before I was going to buy the first samples of the watch, I discovered Tok. Tok is an operating system that is written from the base of it in Rust. It also has something unique that only the FrOSCon operating system matches. FrOSCon as a background is something which is basically a JavaScript interpreter for microcontrollers, which is amazing on its own, but I'm also not a fan of JavaScript, and as I said, enjoying is very important for me. But Tok is a proper operating system. It's preemptive, so you can have many applications running at the same time without like interrupting themselves, but without getting in the way of each other. And that gives me possibilities. Maybe I could load applications at runtime while the watch is running. The user could like upload from the laptop and replace the old one with a new one. This is really quite cool. This is basically giving an app ecosystem to the smartwatch and to the bike computer. I don't think anyone ever did that. I mean, this is so open. This is so obvious also. Why is Garmin not doing that? Well, if they're not doing that, I'm doing that. Yeah, so this is how the Tok entire thing looks like. The project is composed out of the kernel and some supporting libraries. On top of the kernel, you can put different applications. All of them are native. They are machine code, either ARM or RISC-V. In this case, the smartwatch is running on ARM, so I have only ARM to take care of. You could, for example, have one application with a speed meter that would show you the kind of a window in the front that shows your speed. Another application could take care of the clock, and they would be like self-contained. This is kind of an architecturally nice thing, because if you download an application that someone managed to crash, to make it happen that it crashes, it does not crash the operating system. You can keep going and just forget about the application. Maybe the application restarts in the background. Maybe you just stop using it anymore. That is quite cool if you want to imagine the future where people load applications from the internet and run it on your bike computer. But there's a problem. If you have this kind of separation, you have to write a lot more code. You not only have to write the code that does the thing that you want, like, for example, measure speed, but you also have to care about all the drivers. And the architecture becomes more complicated here. As an example, with a compass sensor, the compass sensor is the hardware, but then you have to write a kernel driver. But on top of that, there is the separation between the kernel applications, so you have to take care of this on both sides. You have to write a system call driver, and then you have to expose in the runtime library the actual application programming interface so that applications can make use of it. This makes it actually kind of difficult to code for it, because you have to write everything like 2 or 3 times. This is especially painful in the beginning, which is kind of the beginning because the Tok OS project is not very mature yet. But in comparison to doing something with bare metal, where you basically have just the driver and the hardware, you lose a lot more work. But despite of this, I managed to get a demo quite quickly. This is a demo which shows the current speed. And I think that was the time to make sure that it didn't hang. This is one of the demos that is available in the Jazda project today. Jazda is the name that I decided to give my bicycle computer. This is the same hardware that I mentioned. That's the hardware from Espruino. That's basically, it shows you that the interface for the LCD display is working. It also shows you that there is a library that can draw things. And it also shows you that the GPS sensor is working because those numbers are taken from the GPS. Well, OK, it's a bit of a lie. You can see in the background it's actually lying on a tree. So I actually just uploaded the screenshot here. But you have to believe me, it actually works when you ride the bicycle computer. But as I said, there's a lot of work. Today, there are sensors which typically use Bluetooth to communicate with bicycle computers. There's also the problem that TalkOS, as I mentioned, is not very mature. So it is lacking the concurrency things that I want. It's mostly related to linking and compiler problems that I could probably talk about at a different presentation. But this talk is not about talk. So I'm just going to mention it. Communication between applications is also missing. Communication with a computer that I would do either through Bluetooth or USB is missing because the watch does not actually have USB. It just has Bluetooth, but I cannot have Bluetooth yet. Publishing apps is an entirely different kind of worms. You have to actually have a website, maybe a way of paying things, also a way to upload the applications. Yeah, there's plenty of things to do, but there's also plenty of things to do for fun. And as I mentioned, this is more of a hobby project, so fun is still important. So far, I made a file system, which is especially well made for flash devices, and can also store a lot of time-based data like GPS logs. There's also Raylib that I decided to write as a kind of a drawing library that is especially well suited for monochromatic displays. And there's also Skitram, which is a thing which I haven't published yet, but is going to make sure that those GPS logs fit in the 8 megabytes of memory on my watch. Typically, GPS logs can take 8 megabytes for like 1 hour. No, wait, 8 megabytes. Typically, like there's about 1 megabyte per hour, which is still a lot. I want to be able to really cycle a lot before the memory is full. So I decided to, yeah, maybe I can play with some compression. And I will publish it at some point. But the biggest problem right now is that I'm using GPS. GPS is a radio, and radios, well, GPS is a radio, and radios are expensive in terms of power. They are eating a lot of energy, especially with the calculations. You might know it if you have like a phone and you like to turn on the GPS all the time. The battery is going to run out quite quickly. So I use it to measure the speed, because the speed is the blood of the bicycle computer. Without speed, you don't have a lot to do. On the other side, most bicycle computers today use just Bluetooth low energy to communicate with a sensor on the wheel that counts rotations and decides how far you went, or the sensor on the crank that tells you whether you're pedaling too fast or too slow, or maybe a heart rate sensor. So using those, the Bluetooth low energy, it is also a radio, but this is a radio that does not go 10,000 kilometers away from to here, but it's like a local area. So it takes somehow, I'm not a radio expert, it takes somehow a lot less energy. Sadly, I don't have it. There is a problem with, well, a design decision that the TalkOS made, that they do not allow direct access to hardware from applications. And this means that I cannot take an existing library for Bluetooth support and put it on TalkOS. This will not work because of the security model. I have to write my own separate driver for TalkOS, and Bluetooth is notoriously difficult to implement. So yeah, there's going to be a journey in that way. But also I discovered, after not cycling with a bicycle computer for 10 years, I discovered that the speed is actually overrated. There is a lot of things that you can do with sensors that do not involve speed. Like, here are some of my ideas and some of ideas from others. Wheelie detection. If I do a wheelie, like cycle on one wheel, maybe I can get the bicycle computer to detect that and tell me how many seconds or what distance I covered. That would be quite cool. Like, it wouldn't be useful, but it would be quite cool. I also cycle for OpenStreetMap. Like, there was a time where I cycled every day a couple kilometers to just discover new tracks and put them on the map. But what I was always missing from OpenStreetMap is no one cares about the surface. Then there are tags for roughness. How much will your butt hurt after you travel this road? It is difficult to guess. Sometimes there's gravel, sometimes there's asphalt, but you can have flat gravel and you can have asphalt that is full of holes. No one tells you on OpenStreetMap. And if I have an accelerometer, I can measure vibrations and have some objective measure that I can put on the map. That would be quite cool. I am going to do that, not yet, we're not there yet, but I will do this. Low power navigation, there was a guy who I asked about ideas. He said that he was a driver for Uber Eats or something like that, and he basically did that thing with putting the phone on the handlebars and having navigation from that, but the phone didn't have a battery that lasted enough, so he said, you know what would be useful? If I could put the phone in the backpack, turn the display off, and it would just send the directions to my bike, to my tiny bike computer in the front. Yeah, that would be quite cool. He would be able to ride all day without the battery running out. So there's another thing, sonar chase mode. Who is here familiar with racing games? Not many people. There is a thing that was patented in '98, so long enough, thankfully, where you have like a ghost car that you try to chase, but the ghost car doesn't really exist on the track. You can move through it. It's actually your recording of your previous run. So if you do a circle on the track, the computer saves the track, saves save your performance, and you can race yourself from the past again. And I was thinking this would be quite cool to put on the bicycle and be able to race your previous time from the same track. You would be able to, like, the bike computer could calculate if you are faster or if you are slower, and it could like inform you in some way, perhaps like a ping with kind of a sonar way. This, the sonar works that if you are close to something, the ping comes back immediately, so you hear beep beep. And if something is far away, you could hear like beep, beep, kind of longer. I don't know, it's just an idea. You could invent a lot of things, is my point. And for that, I actually need community. Sorry. With the power of open source is that there's a lot of ideas and a lot of interests, and a lot of people are empowered to do things, especially if they are easy. And I'm counting on other people who might have ideas about what do you want to do with your bicycle computer. Do you actually need something? Or maybe you are going to be taking a shower and something comes into your head. You can do it. With an open source bike computer, you can actually have a chance. You are not going to need like an NDA or a job at Garmin to make your idea true. So we are selling development kits at the entrance. This is what a development kit looks like. And this is what the stand at the entrance looks like. Also, there are stickers. You can buy them at the entrance here at FrOSCon, or you can jump on chats. I am usually hanging out there. If you decide later that you want one, then maybe we can chat about this. Or if you are just interested in hearing where this project leads, there's always chat. And this is my favorite part. As I mentioned, I suck at hardware. Maybe there are hardware hackers here. Maybe someone could help me design a new version that would be also open hardware, which would have a beeper with sound, or which would have a USB connection. I don't know. But there's a lot of possibilities, and the hardware that I have, this is a smartwatch. This was a design for a smartwatch. It also has the, the funny thing where it has a heart rate sensor. Well, my bicycle computer does not have a heart, so it's kind of useless here. There are possibilities. If we have hardware hackers, then I would be really happy to hear from you and try to design a new version. So yeah, the project has a website. It's jazda.org. You can always find me on Matrix. I also have a Fediverse account on Fostodon if you want to chat in more Twitter way. You can also complain at me or engage in some other way. I also have a blog that I write about, not just about this project, but about random projects in general. And I think I'm going to post this presentation on it as well. Yeah, that will be it. Do you have any questions? By the way, I have this, one of the smartwatches here. This is the second demo that displays a map, but it needs GPS. So sadly, indoors, it doesn't really receive anything, so there's nothing on the map. But if you want to take a look at this, also I have stickers.